Hello children, hope you are healthy and safe. Now for class 8th, we begin with the second chapter, that is exponents. You have already studied exponents last year, but we will add a few things this year to what you have already studied. Integers as exponents. Okay, now if you see the first example, 4 into 4 into 4 is equal to 4 raised to the power 3. Is read as 4 raised to the power 3. Now if you see there, the 3 is the exponent, that is the power, and 4 is the base. This form, when you write 4 raised to the power 3, this is called exponential notation. Now if I have to use the rational number, we are done for the rational number last year. Similarly for rational numbers, 2 upon 5 into 2 upon 5 into 2 upon 5 into 2 upon 5 can be written in the exponential notation as 2 upon 5 raised to the power 4. Similarly for minus 2 upon 5 into minus 2 upon 5 into minus 2 upon 5 into minus 2 upon 5 is equal to minus 2 upon 5 raised to the power 4. So in general we can say if a upon b is raised to the power n, that means it is equal to a raised to the power n upon b raised to the power n. Now we will talk about positive integral exponents of a rational number. Now what do you mean by positive integral exponents? Where the power is positive. Okay, so now let us see. Let a upon b be any rational number and n be a positive integer. Then a upon b into a upon b into a upon b into a upon b n times is equal to a upon b raised to the power n. We can see the example here. 2 upon 3 into 2 upon 3 into 2 upon 3 into 2 upon 3 is equal to 2 upon 3 raised to the power 4 when the power is positive integer. And maybe the rational number is negative, but again the power is positive. Minus 2 upon 3 into minus 2 upon 3 into minus 2 upon 3 is equal to minus 2 upon 3 raised to the power 3. Now we'll talk about negative integral exponents. What do you mean by negative integral exponent? When a upon b be any rational number and n be a positive integer. Then, now because we want the power to be positive, so then a upon b raised to the power minus n is equal to b upon a raised to the power n. We take the reciprocal and the power becomes positive. For example, 2 upon 5 raised to the power minus 3 is equal to 5 upon 2 raised to the power 3. Now we'll talk about laws of exponent. Okay, now what do you mean by laws of exponents? The rules that we follow while we solve. So if a upon b is a rational number and m and n are integers, then the first rule, that is multiplication rule, that is a upon b raised to the power m into a upon b raised to the power n is equal to a upon b raised to the power m plus n. Whenever bases are the same and they are multiplied, the powers are added. Now let us come to the second rule, that is called the division rule. A upon b raised to the power m is divided by a upon b raised to the power n is equal to a upon b raised to the power m minus n. Now whenever the bases are the same and they are divided, then the powers are always subtracted. Now let us come to the third rule, that is called power of power rule, where a upon b raised to the power m is further raised to the power n. Whenever the powers are separated by a bracket, they are always multiplied. That is equal to a upon b raised to the power m into n. Now let's come to the fourth rule, that is power of product rule. A upon b into c upon d raised to the power n. We write it as a upon b raised to the power n into c upon d raised to the power n. When the bases are not the same but the power is the same, we write it in this way. Now fifth one, a upon b divided by c upon d raised to the power n. Again the bases are different and the power is the same. We write it in this way as a upon b raised to the power n upon c upon d raised to the power n. Now come to the sixth rule, that is called negative exponent. A upon b raised to the power minus n. We take the reciprocal so that the power becomes positive, that is equal to b upon a raised to the power n, where n is a positive integer. Now let's come to the seventh rule, that is zero exponent. A upon b raised to the power 0 is always equal to 1. Any rational number, if it is raised to power 0, it becomes equal to 1. In the next video, I will explain you the examples related to the given laws. Thank you, children.
Okay, now we'll come to the solved examples. First, evaluate. First, 5 raised to the power minus 3. Second, 1 upon 3 raised to the power minus 4. Third, 5 upon 2 raised to the power minus 3. Fourth, minus 2 raised to the power minus 5. Fifth, minus 3 upon 4 raised to the power minus 4. Now, always remember, when the power is negative, we follow this rule. That means we take the reciprocal and then you will find the rational number. Now, here we don't want to write in the exponential form. Here we find the rational number for it because we have to evaluate. Okay, first one, 5 raised to the power minus 3. We take the reciprocal to make the power positive. Is equal to 1 upon 5 raised to the power 3. Okay, is equal to, now 1 upon, now 5 multiplied 3 times becomes 125. So 5 raised to the power minus 3 is equal to 1 upon 125. See the second example. 1 upon 3 raised to the power minus 4 is equal to 3 upon 1 raised to the power 4. That means 3 to be multiplied 4 times with itself is equal to 81. Now third one, 5 upon 2 raised to the power minus 3 is equal to 2 upon 5 raised to the power 3, as we have taken the reciprocal. So 2 raised to the power 3 and 5 raised to the power 3. Okay, 2 into 2 into 2 becomes 8. Same thing for 5 is equal to, if you're multiplying 5 3 times, is equal to 125. So your answer is 8 upon 125. Now let's come to the fourth one, minus 2 raised to the power minus 5. Again, you have to take the reciprocal, 1 upon minus 2 raised to the power 5. That is equal to 1 upon minus 2 raised to the power 5. Multiply minus 2 5 times. That is equal to 1 upon minus 32. Now always remember, if the minus sign is in denominator, we multiply both numerator and denominator by minus 1. So that the minus goes in the numerator now. So it's equal to minus 1 upon 32. Now see the fifth one, minus 3 upon 4 raised to the power minus 4. That is equal to 4 upon minus 3 raised to the power 4. Okay, because minus is in the denominator, we take it, we multiply both numerator denominator by minus 1. So it goes to the numerator. So minus 4 upon 3 raised to the power 4 is equal to, now multiply minus 4 4 times. That is equal to 4 raised to the power 4. Why? Because if negative integer is multiplied even number of times, it becomes positive. Clear? And 3 raised to the power 4 4 times. So it becomes 256 upon 81. Now see the second question, evaluate. Now here we applied the rule, when the power is negative, we take the reciprocal and then we, what do? And then we multiply. Okay. Now evaluate. See question number 2. In this, if you see the bases are the same, all the bases are the same. So we will follow the first rule, that is multiplication rule. So 2 upon 3 raised to the power 3 into 2 upon 3 raised to the power 2. We will add both the powers. Now see the first example. So it becomes 2 upon 3 raised to the power 3 plus 2. That is 2 upon 3 raised to the power 5. Now here we cannot leave the answer in this form. That is 2 raised to the power 5 upon 3 raised to the power 5. We will multiply 2 5 times and 3 also 5 times. So is equal to 32 upon 243. Same is in the second one. 4 upon 7 raised to the power 5 into 4 upon 7 raised to the power minus 3. That is equal to 4 upon 7 raised to the power 5 plus minus 3, because both are unlike signs, so we subtract. So 4 upon 7 raised to the power 2. So 4 raised to the power 2 and 7 raised to the power 2 is equal to 16 upon 49. Similar is the third one. 3 upon 2 raised to the power minus 3 and into 3 upon 2 raised to the power minus 2. Now if you want, you can take the reciprocal and then solve. But because it's a multiplication, we can directly add. So 3 upon 2 raised to the power minus 3 plus minus 2, that is 3 upon 2 raised to the power minus 5. Okay, because the power is minus, now we'll take the reciprocal. So 2 upon 3 raised to the power 5, that is 2 raised to the power 5 and 3 raised to the power 5. Multiply 2 5 times and 3 5 times. So it becomes equal to 32 upon 243. Now the next one, fourth part. If you see 8 upon 5 raised to the power minus 3 into 8 upon 5 raised to the power 2. That is equal to add both the powers. So 8 upon 5 raised to the power minus 3 plus 2. Now one is negative and one is positive, so we subtract. So we get 8 upon 5 raised to the power minus 1. Now because the power is negative, we take the reciprocal. So answer becomes 5 upon 8. Now I hope you are clear with these examples. Now we begin with the third example. Just see, evaluate. That is 3 upon 8 raised to the power minus 2 into 4 upon 5 raised to the power minus 3. Both bases are different and both powers are different. Only that the powers are negative, so we will use the reciprocal of both. So 3 upon 8 raised to the power minus 2 into 4 upon 5 raised to the power minus 3 is equal to, first take the reciprocal. So 8 upon 3 raised to the power 2 into 5 upon 4 raised to the power 3. Okay, so 8 into 8, 64. 3 into 3, 9. Now 5 multiplied 3 times, 125. 4 multiplied 3 times, 64. So we multiply them. 64 upon 9 into 125 upon 64. It can be reduced. 64 ones are and 64 ones are. What is left? 125 upon 9, which is the answer. Now see the fourth example. Again evaluate. Minus 2 upon 7 raised to the power minus 4 into minus 5 upon 7 raised to the power 2. Again if you see, both bases are different and both exponents are different. So again, because one is negative, so first we will take the reciprocal. So minus 2 upon 7 raised to the power minus 4 into minus 5 upon 7 raised to the power 2 is equal to 7 upon minus 2 now, because we have taken the reciprocal, raised to the power 4 into minus 5 upon 7 raised to the power 2. Because the negative minus sign should not be in the denominator, so we multiply both with minus 1. So the minus sign goes to the numerator. So it becomes minus 7 upon 2 raised to the power 4 into minus 5 upon 7 raised to the power 2. Now we multiply them. Now once you multiply them, what do we get? We get minus 7 raised to the power 4 and 2 raised to the power 4. Now this is minus into minus 5 raised to the power 2 and 7 raised to the power 2. That is equal to 7 raised to the power 4, because it was minus 7, but when you multiply even number of times, it becomes plus 7. So 7 raised to the power 4 into 5 raised to the power 2 upon 2 raised to the power 4 into 7 raised to the power 2. That is equal to 7 raised to the power 2. Now why only 2 is left? Because in the denominator you had 7 raised to the power 2. In the numerator you have 7 raised to the power 4. So 4 minus 2, only in the numerator 7 raised to the power 2 is left. into 5 raised to the power 2 upon 2 raised to the power 4. That is equal to 49 into 25 upon 60. Question number 5 again, evaluate. Now just see, bases are the same. Minus 1 upon 4 raised to the power minus 3 into minus 1 upon 4 raised to the power minus 2. Okay, what do we do? That is minus 1 upon 4 raised to the power minus 3 into minus 1 upon 4 raised to the power minus 2. This is equal to, first take the reciprocal. Or even if you add directly, will not be wrong. Now if you add directly, it becomes minus 3 plus minus 2, that is minus 5. Because it is minus 5, then you can take the reciprocal. Okay, but they have taken the reciprocal first. So 4 upon minus 1 raised to the power 3 into 4 upon minus 1 raised to the power 2. So it becomes minus 4 raised to the power 3 into minus 4 raised to the power 2. Now add both. So minus 4 raised to the power 3 plus 2 becomes minus 4 raised to the power 5. That is equal to minus 1024. Okay, now let us come to the next example, that is 6. That is power of power rule. Now what is that power of power? Where the powers are separated by a bracket. If you see, both the powers are separated by a curly bracket. So it is minus 3 upon 2 raised to the power 2, which is further raised to the power minus 3. That means we multiply both the powers here. See, minus 3 upon 2 raised to the power 2 into minus 3. That is equal to minus 3 upon 2 raised to the power minus 6. Because the power is negative, we take the reciprocal. So it becomes 2 upon minus 3 raised to the power 6. Again, the denominator has got the minus sign. So we multiply numerator and denominator by minus 1 so that the minus goes to the numerator. So it becomes minus 2 upon 3 raised to the power 6. Both are to be multiplied 6 times. So you get 64 upon 729. Now, why minus became plus? Because minus 2 is raised to the power 6, which is even. So any negative integer, if is multiplied even number of times, it becomes positive. So that is why you get the answer as 64 upon 729. Now I will explain you the 7th example, that is simplify. Okay, whenever you simplify, we use more than one rule. So first part, it is 2 raised to the power minus 1 into 5 raised to the power minus 1 in the bracket, which is raised to the power minus 1, divided by 4 raised to the power minus 1. First thing, we will solve the bracket part because both the powers are negative. So we take the reciprocal and then we multiply. So it becomes 1 upon 2 into 1 upon 5 in the bracket raised to the power minus 1, divided by 4 upon 1 raised to the power minus 1. Now here we will multiply and here we will take the reciprocal as the power is negative. So it becomes 1 upon 10 raised to the power minus 1 divided by 1 upon 4. Now we will solve the first part because the power is negative. So we'll take the reciprocal again. So 10 upon 1 divided by 1 upon 4. Because it's a division sign, so we'll take the reciprocal of the second one and multiply. So 10 into 4, that is equal to 40. Now see the second part. Now 4 raised to the power minus 1 plus 8 raised to the power minus 1 in the bracket divided by 2 upon 3 raised to the power minus 1. Now, if you see the bracket part, both the powers are negative, and even the second part, if you see of the equation, there also the exponent is negative. So we'll solve both. Okay. So first in the bracket, we take the reciprocal of both the numbers and then add. So 1 upon 4 plus 1 upon 8 divided by, we take the reciprocal of this, becomes 3 upon 2. Now take the LCM of 4 and 8. So the LCM is 8. Okay, now 8 divided by 4 is 2. So 2 into 1 is 2. Again 8 divided by 8 is 1. So 1 into 1 is 1. So 2 plus 1 upon 8 divided by 3 upon 2. We add, so we get 3 upon 8 divided by 3 upon 2. That's a division. We take the reciprocal and we multiply, or we take the multiplicative inverse and we multiply. So it becomes 3 upon 8 into 2 upon 3. Now we can reduce 3 ones are 3 ones are. So 2 ones are and 4 times. So 1 into 1 is 1 and 4 into 1 is equal to 4. So it becomes 1 upon 4. Okay, now we'll discuss example number 8. Simplify. Whenever you simplify, we use more than one rule. Okay, just see here 1 upon 2 raised to the power minus 2 plus 1 upon 3 raised to the power minus 2 plus 1 upon 4 raised to the power minus 2. Okay, as all the powers are negative, we will take the reciprocal first. So, the reciprocal will be 2 upon 1 raised to the power 2 plus 3 upon 1 raised to the power 2 plus 4 upon 1 raised to the power 2. Okay, so we write it like this because this one we can omit now. So 2 raised to the power 2 plus 3 raised to the power 2 plus 4 raised to the power 2. Okay, so 2 into 2, 4, plus 3 into 3, 9, plus 4 into 4, 16. We add all and we get that is equal to 29. That is the answer. Now let us come to example number 9. By what number should 1 upon 2 raised to the power minus 1 be multiplied so that the product is minus 5 upon 4 raised to the power minus 1. So let the number to be multiplied be x. So first we will write it in this form. So let the required number be x. Then, okay, we multiply x into 1 upon 2 raised to the power minus 1 equal to minus 5 upon 4 raised to the power minus 1. Okay, because both the powers are negative, we will take the reciprocal of both. So x into 2 upon 1 is equal to 4 upon minus 5. Now always remember, if minus is in the denominator, we multiply numerator and denominator both by minus 1 so that the minus goes in the numerator. So it becomes equal to 2x is equal to minus 4 upon 5. Now x is equal to, because whatever was with x, we take it to the right hand side. So it was 2 into x. Because it was multiplied here, it becomes a division here. So it becomes x is equal to 1 upon 2 into 4 upon 5. We can reduce them. 2 ones are, 2 twos are. So we get 1 into minus 2 is minus 2. And 1 into 5 is 5. So hence the required number is minus 2 upon 5. Now let us come to example number 10. By what number should minus 3 upon 2 raised to the power minus 3 be divided so that the quotient is 9 upon 4 raised to the power minus 2. Okay, so let the required number be x, or number with which we divide is x. Okay, so we make the equation minus 3 upon 2 raised to the power minus 3 upon x, because we are dividing by x, is equal to 9 upon 4 raised to the power minus 2. Now this x, if I bring it to this side, because it was a division, it becomes a multiplication. And because both powers are negative, we take the reciprocal to make the powers positive. Okay, so minus 3 upon 2 raised to the power minus 3 becomes minus 2 upon 3 raised to the power 3 equal to 9 upon 4 raised to the power minus 2 becomes 4 upon 9 raised to the power 2. And because it was a division, it becomes a multiplication into x. Now that implies that minus 2 raised to the power 3 upon 3 raised to the power 3, that is equal to 4 raised to the power 2 and 9 raised to the power 2 into x. That is again, it implies that minus 8 upon 27, because minus 2 into minus 2 into minus 2 is equal to minus 8. 3 into 3 into 3 is equal to 27. That is equal to 4 4s are 16. 9 9s are 81 into x. Now, whatever is with x, because it is a multiplication, it becomes a division on the other side. Or we take the multiplicative inverse and multiply. So now it becomes x is equal to minus 8 upon 27 is already on this side. Now we take the reciprocal of this and multiply. So into 81 upon 16. We reduce 8 ones are, 8 twos are, 27 ones are, 27 threes are. So minus 1 into 3 becomes minus 3. And 1 into 2 is equal to 2. So x is equal to minus 3 upon 2. So hence the required number is minus 3 upon 2. Now I will send you a link so that you get the help for doing exercise 2A in the notebook. Thank you, children.